Welcome back to our third lesson on physical quantities. The last time we talked about what a physical quantity was, that is in the first video. We also talked about the types of physical quantities that we have. In the second video, we looked at how to group some quantities under a base quantity and a derived quantity. Now in this lesson, we are going to look at a few quantities as well. The other type of quantities, that is the scalar and the vector quantity. Now for the very first time, for those who are just watching this for the very first time, we said that a quantity is a quantity is anything that can be measured at a lab or can be determined by means of a calculation. Now a physical quantity is a physical property of a system, okay, which has a unit attached to it. Now the physical property of the system is measured, has a numerical value, has a measure. Now the unit determines what type of quantity it is, and the unit attached to it gives it a meaning. I hope you're okay. So now we said that we have four main quantities. That is base quantity, we have a derived quantity, then we have a scalar, and then a vector quantity. However, most of the books just refer to a scalar and a vector quantity, but then the grassroots of it is a base quantity, and we say that the base quantity is any quantity which cannot be derived from any other quantity, right? And then a typical, we give example as mass, time, length, distance. All these ones are examples of base quantities. Okay, now length and distance are the same thing. Sometimes we use them interchangeably. I hope you understand. Then we said that in some books too, you see they refer to them as fundamental quantities. Now all base quantities are fundamental quantities, but not all fundamental quantities are base quantities. We have 7 fundamental quantities, right? But we have 3 base quantities. Take note of that. Now the 3 base quantities are mass, time, and then length. These are the 3 base quantities. So if you take any quantity, these 3 things, these 3 quantities has some sort of appearance in them. I hope you understand. Now the other fundamental quantities, if we talk of fundamental, we have mass, time, length, okay, we have temperature, we have electric current, we have amount of substance, all right, and then we also have luminous intensity. These are the 7 main fundamental quantities that we have, so you have to take note of that as well. And then the next one, we said a derived quantity. Now a derived quantity is any quantity which is obtained as a result of putting 2 or more base quantities together. And so if I put a base quantity, 2 lengths which are base quantities, if I put them together, and when I say put them together, is either by multiplication or division, all right? Now, and so if I put length times length, I'll get area. If I put together length times breadth times height, it gives me volume. Now if I divide the mass of a substance by the volume, then I will get density. Okay, now if I also divide, or if I multiply the mass of a body and its acceleration, then I get force. So these are to mention a few of derived quantities. Then the third one is the scalar quantity, and that is what we're looking at, some few examples. But then we define what a scalar quantity is. We said that a scalar quantity is any quantity that has magnitude but no direction. And so we said that if I make reference to a distance, if I say 5 meters, 5 meters what? Now the meters attached to it is the unit. The 5 is the numerical value, but the meters is telling me that I'm talking of distance, right? And distance or length, okay, distance is the length between 2 points. And so if I make reference of 5 meters, 5 meters what? But if I say 5 meters north, I have added an additional information, and therefore it now ceases to be. It now gives you a definitive understanding, a definitive direction, a definitive expression of what the 5 meters is. I hope you get it. And so a scalar quantity, we say that a scalar quantity is any quantity that has magnitude but no direction. And some examples of scalar quantities, we have mass, we have time, we have length, all right? Then we have speed. Are you okay? We have work. All these ones are but a few examples of scalar quantities. They all have magnitude, but they don't have direction. Then the fourth one has to do with a vector quantity. Now, a vector quantity has both magnitude and direction. And going back to the previous example that I gave, 5 meters east. And so 5 meters, not anywhere but east. 10 meters north, not anywhere. 10 meters, I'm not measuring 10 meters in any direction, but in the north, heading to the north or to the south, okay, or to the left or to the right. And so the addition of the word right, more or less, is just like an adjective. An adjective qualifies a noun. It brings out a further meaning to whatever the noun is, whatever the noun is, or whatever we are talking about. And so if we say the red car, the car is a noun. I could have said the car, but what kind or type of car am I referring to? I'm referring to the red car. And so red here now describes the car. It gives you, the red added gives you additional information of what kind or type of car that we are talking about. The same thing applies to that of a vector quantity. So a vector quantity has magnitude, but no direction at all. I hope you get it. And so in this lesson, we are going to try as much as possible and then just classify these quantities on the board into a scalar and a vector quantity based on the understanding that we have, based on the explanation that I've given. And so this is just a simple example, all right? Classify the following quantities as either a scalar or a vector quantity. Classify the following quantities as either scalar or vector, okay? Not a scalar, either scalar or vector quantity. I hope you understand. Now, the first one is mass. The second is length. The third is force. The fourth one is work. The fifth is time. The sixth is displacement. The seventh is velocity. And then the eighth is speed. So now we are going to put these ones together. We are going to group them under these headings. That is a scalar and a vector. Now, to be able to do that, you have to remember the definition of a scalar quantity. All right? And when I was presenting, I even mentioned almost all of them. So if we're paying attention, this should be, I gave you a heads up on it. Okay. So now we are looking at mass. Mass has a measure. The amount of matter contained in a body is the mass of the body. But then it has no direction. And therefore, mass here becomes a scalar quantity. So I put it down here gently. So have mass as a scalar quantity. And this is what we are going to do. Anytime we put down, we take out 1, I'm going to cross it so that we don't get confused. So we have mass out. Now the next one is length. Length, okay, is the interval between 2 points. Length is the interval between 2 points. And so interval can be in any direction. But if I did not specify the direction, and therefore if I say length, interval between 2 points, that's it. Is it to the left or to the right? No additional information was given. And so it makes length also a scalar quantity. So length, and then so we cross it out as usual. Length is out. We have taken care of that one. And then the third one is force. Now, force, from the basic definition, from a layman's point of view, force is a push or pull on an object. What does it do? It tends to change a body's state of rest or uniform motion along a straight line. So if I'm changing, then it means it is moving in a different direction. If I push an object this way, I am pushing it towards a particular direction. If I pull it, I'm pulling it towards myself. All right? And therefore, an object lying down this way, the moment I touch it, I change its direction, I change its position. Okay? And therefore, force becomes a vector quantity because it has magnitude and it has direction as well. Okay? And so force here becomes a vector. So I put it on my right. Force. Then I cross it out as usual. Then the next one is work. Okay? Work can be defined. All right? Work can be defined as the force exerted on a body through a distance. Okay? It is force times distance. That is work. Force times distance. However, in which direction is the work heading? Just work. We don't work north, we don't work south, we don't work east or west. All right? And so work here automatically becomes a scalar quantity. So we have work also down here, time. Then when I was presenting, I believe you heard what I said. Now 12 o'clock, when I say, oh, what is the time? It's 12 noon. 12 noon. 12 noon north or 12 noon south. There is no direction. Time is time. We don't refer to time to the left or to the right. Okay? And so time here also becomes a scalar quantity. So time is a scalar. Now displacement, which is a bit tricky. Okay? Displacement is the interval between 2 points in a specified direction. That is the definition. Displacement is the interval between 2 points in a specified direction. And so if you recall, I made reference to 10 meters. Now 10 meters is length, right? But if I say 10 meters north, then it changes from length or distance to displacement, because now I've added additional information. I've added direction to it. More or less, I've given it a purpose. Okay? So displacement here is a vector quantity. So I'm going to put it on the right. Displacement. And that's it. So this one is also gone. Then the next one is velocity. Velocity. Velocity is defined as the time rate of change of displacement. The time rate of change. And anytime you hear rate, okay, in mechanics, then we are referring to, we have some component of time in there, okay? Or to break it down, velocity is simply defined as displacement divided by time, okay? Displacement divided by time, or distance moved in a specified direction divided by the time taken to cover that distance. That is the velocity. I hope you get it. And so I said in a specified direction. Take note, anytime you hear specified direction, then we are talking of velocity. If you don't hear a specified the phrase in a specified direction, but you hear north, south, east, and west, north, northeast, or heading towards an angle, a bearing, then you should know that we have a particular direction that we are referring to, a particular frame of reference. Okay, and so therefore we are talking of a vector quantity. I hope you understand. And so the next one, velocity, what do you think it will be? Your guess is as good as mine. It will be a vector quantity. Okay, so velocity comes to the right. That is gone. Then we have the last one. Now, velocity is the time rate of change of displacement, right? And we said that velocity is also defined as displacement or distance moved, or the length of interval between 2 points in a specified direction divided by the time. However, velocity and speed, they have the same characteristics. However, speed is simply the length, the ratio of the length of interval between 2 points divided by the time. Take note, there is no mention of a specified direction. And so, speed is a scalar quantity. All right? Speed becomes a scalar quantity. And that's all. We cross that one out. And so, from the question that we looked at, from the example that we had, for out of these 8 examples or 8 quantities, we have been able to group them under the heading scalar and a vector quantity. And so scalar quantities are, to wrap it up, the scalar quantities are mass, length, work, time, and speed. Mass, length, work, time, and speed. And then the vector quantity is force, displacement, and velocity. I hope you've understood it now. You now know the difference between a scalar and a vector quantity by definition, and then some examples of a scalar and a vector quantity. Thank you very much for joining me today. I hope to see you in the next video. All right, watch out for the next video, and we'll be looking at units and measurements. Okay, have a nice day. Bye.